안녕하세요. 안녕하세요. 서울 이더리움 미덕 포고나이저 정수입니다. 좀 늦게 오시는 것 같아서 시작을 좀 늦췄어요. 지금 15분인데 지금 한 3, 4분 뒤에 시작을 하도록 하겠습니다. 그리고 뒤쪽에 지금 다과가 준비되어 있으니까요. 혹시 들으시다가 당이 떨어지신다거나 하면 뒤쪽에 다과를 드시면 돼요. 지금 물도 있습니다. 그리고 지금 입구 쪽에 리셉션 쪽에 그 스티커가 있어요. 이더리움 스티커를 저희가 제작을 했는데 서울 이더리움 가실 때 두세 장씩 가지고 가시면 좋을 것 같습니다. 노트북 같은 데 붙여야 돼요. 그러면은 시작을 할 텐데요. 일단 선망할 때 저희 코어가나이저 좀 한 분이신 준희 씨가 나와서 웹스킬 파운데이션이랑 그다음에 웹스킬 파운데이션 그다음에 그 패러티 안쪽에 지금 포커다 팀이 왔어요. 패러티 테크놀로지 안쪽에 포커다 팀이 와서 팀조회를 간단히 얘기가 나서 그 다음에 패러티 팀에서 2개월 정도 올라와서 발표를 하고 그다음에 그 옆에 로봇가 이어서 발표를 하고 진행하도록 하겠습니다. 발표는 15분에서 20분, 25분 정도 될 것 같고요. 질문 있으시면 질문 있으시면 또 15분에서 20분에 발표가 있고 발표 끝난 다음에 질문을 해주시면 될 것 같습니다. 중간중간 발표해 주셔도 좋아요. 혹시 좀 영어가 좀 아니에요. 듣는데 어려우신 분 계신가요? 영어 듣는데 어려우신 분? 다 들으시는 거죠? 알겠습니다. 그러면 100% 알아듣는다고 얘기했고 거의 지금부터 영문 세션으로 하도록 하겠습니다. 그럼 코어가나이저 이준희 씨 계실 거예요.
저는 그 코어가나이저 이준이라고 하고요. 수도 미덕을 많이 다녀서 익숙한 분들이 많아서 좀 질리실 텐데 저는 어쨌든 여기서 이런 걸 조직하고 있는 사람이어서 막 여기저기 좀 많이 돌아다녔습니다. 저희 일단 간단히 좀 소개를 드리면 저희 미덕 같은 경우는 저희가 지금 공동 조직자들이 계속 주최를 하다 보니까 이제 원래 성격을 조금 잃어버리기 시작했어요. 저희는 원래 오픈 미덕이고 누구나 참여하고 이제 누구나 본인이 소개하고 싶은 것들이 있으면 그래도 이더리움과 크게 동떨어져 있지 않은 이상 그런 것들을 소개할 수 있는 자리가 점점 돼야 되는데 저희가 자꾸 너무 무거운 팀을 데려오고 저 사람도 발표하는데 내가 저기서 뭘 하지 약간 이런 부담감을 많이 느끼시는 것 같아요. 그래서 저희가 원래 취지는 그게 아니고 언제나 발표할 수 있으니까 저희 대신 막 다단계나 스캠이 들어와서 그럴 수는 없잖아요. 그래서 저희 나름대로 어떤 기준을 가지고 여러분이 먼저 컨택을 해주시면 언제든 그 발표할 기회를 드리고 저희가 그래도 한 1,400명 정도가 되는 분들이 어쨌든 가입되어 있으시니까 여러분 생각과 좀 맞으신 분들이 같이 또 참여를 해주실 거예요. 저희도 같이 조직하는 도울 거니까 편하게 언제든 말씀하고 싶으신 게 있으시면 연락 주시면 될 것 같습니다. 그렇게 이제 저희 취지를 좀 밝히고요. 일단 그 이더리움 미덕에서 지금 후원을 해주시고 계신 분들 먼저 좀 소개를 드리면 이제 좀 오래되신 분들이 이제 거의 다 아실 거예요. 광주전자 유통은 소프트웨어 도매업을 하고 계신 도매업을 하고 있는 업체고요. 모노스 같은 경우는 채굴 장비 업체, 그리고 기성 같은 경우에는 거래소를 운영하고 있고요. 코인플러그 같은 경우는 지금 홈페이지에 떠있는 블록체인 컴퍼니라고 되어 있는데 관련된 SI 사업도 많이 하고 계시고 이제 거래소, 지갑 다양한 사업을 또 하고 계셔서 국내에서 조금 앞서 나가고 있는 블록체인 회사 중에 하나고 마이닝 풀 허브 같은 경우도 채굴 풀을 운영하고 계시고 동시에 소프트웨어를 동시에 판매하고 계시는 업체입니다. 그리고 제가 가장 좀 자랑스러워하는 부분이 여기 보이실지 모르겠지만 이분들이 다 개인 후원이세요. 이더리움 투자자셨던 분들인데 이더리움으로 내가 돈 좀 벌었으니까 좀 사회적인 기여를 좀 해야 되겠다라고 생각을 해서 이제 직접 조금씩 모아서 기여를 해주신 분들이에요. 간단하게 소개를 드리면 파브르라는 분 같은 경우는 좀 게임 디자인 쪽에서 좀 오래 하고 계신 분이시고 저희 취지가 마음에 든다고 하셔서 좋으셨고 나빌레라는 분 같은 경우는 굉장히 오래된 투자자셔서 이번에 저희 뜻을 같이 해주셨고 알스타라는 분도 이쪽 관련 업무를 보시면서 저희 그냥 후원만 해주신다고 그러고 그 영번방이라고 이제 핫톡을 좀 많이 하시는 분들은 가끔 듣는 방이 있는데 뭐 소문으로는 명당 10,000개가 있어야만 들어갈 수 있는 방이다라는 소문으로 다니는 방인데 그건 거짓말인 것 같아요. 네, 그래서 이분들이 지금 후원을 해주고 계세요. 그리고 저희가 지금 후원을 또 언제나 받고 있거든요. 근데 저희가 후원을 현금으로 받지 않고 항상 이더로만 받아요. 그래서 전에 모아놨던 이더, 그러니까 현금도 받긴 받는데 웬만하면 이더로 받고 저희가 이더로 받아놓으면 나중에 편해요. 왜냐면 저희가 2만원, 3만원대 받아놓은 이더가 지금 좀 많이 커서 스스로 이제 저희 자산을 물려주고 있는 그런 형태라서 여러분이 뭐 후원을 좀 해주시면 감사하겠습니다. 그리고 오늘 그래서 저희가 폴카닷에 대해서 폴카닷 팀을 이제 모시고 설명을 드리는데 그냥 전체적인 개념은 거의 다 알고 계실 거예요. 어차피 저희가 미더에도 소개를 드렸었고 그래서 그냥 조금 헷갈리실 수 있는 부분이 폴카닷은 뭐고 페리티는 뭐고 웹3 파운데이션은 도대체 뭐길래 이렇게 서로 엉켜 있느냐라고 생각이 드실 거예요. 이제 간단하게 말씀드리면 폴카닷 같은 경우에는 하나의 프로젝트라고 생각을 하시면 돼요. 하나의 프로젝트가 진행되고 있는 거고 그 프로젝트를 진행하고 있는 팀이 페리티 팀인 거예요. 네. 근데 그 페리티 팀에 폴카닷을 진행하는데 서포트를 해주고 있는 업체가 그 단체가 웹3 파운데이션이라고 생각하시면 돼요. 어떻게 보면 그 중간 사이에 있는 거라고 보시면 돼요. 웹3 파운데이션이 페리티 전부의 프로젝트를 미는 건 아니고 그 중에서 폴카닷 프로젝트를 같이 밀고 있어요. 그렇게 지금 구성이 돼 있어서 이제 이게 생긴 지 한 3달밖에 안 됐어요. 웹3 파운데이션 같은 경우는. 그래서 웹3 파운데이션에 대해서 일단 첫 번째로 소개가 되실 거고 두 번째로 폴카닷에 대한 기술적인 소개가 진행이 될 예정입니다. 그래서 여러분 궁금하신 점 있으시면은 저희가 발표 시간 말고도 일부러 뒤에 시간을 길게 잡아놨어요. 워낙 궁금하신 게 많을 것 같아서. 그래서 막 부끄러워하지 마시고 다 물어보시고 싶으신 거 있으면 다 물어보시고 네트워크도 해서 그리고 개발자 풀을 지금 데려가려고 목표를 해서 지금 전 세계를 돌아다니고 있거든요. 그러니까 여러분들이 국내 말고 다른 세계도 있다. 페리티랑도 놀아볼 수 있다. 이런 기회를 가지실 수 있으니까 한번 다양하게 얘기해 보시면 좋을 것 같습니다. 네, 그러면 이제 바로 좀 발음을 정확히 뭔지 모르겠는데 비안 뭐 이렇게 부른다고 하더라고요. 비안이 먼저 이제 소개를 해주실 거예요. 그래서 한번 박수로 비안 모시도록 하겠습니다.
Pleasure to be here. Thank you so much for organizing this meetup event. And also thank you so much for trying to translate the slides. I know it's not an easy task, but thank you. First of all, I would like to ask you, if you don't understand stuff, just call in, just ask me please. I want to make it as comprehensive as possible. I know it's quite a tough topic and it's quite technical, but we want to try to break it down a little bit. So I'm Bjorn Wagner. I'm with Parity Technologies, same as my friend and colleague Robert Habermeier in the back. Even though I'm an engineer, I actually work mostly on the business side today. But my friend Robert is highly technical and can answer a lot of questions later on. So what I would like to begin with is give you a little bit of a high-level overview, where we come from, why we're here today, and what we're trying to achieve. So, here we go. Our names. So, to understand why we are doing all this here, why we're here, and why we're trying to build these new technologies and new communities, is really because over the last years, or even decades, we've seen that our current infrastructure, web infrastructure, is highly prone to errors, attacks, and compromise. And originally, I think our co-founder, Kevin Wood, described the Web3 vision in 2014, in the early days of Ethereum, that really revolves around having these very interesting types of technologies such as peer-to-peer technology, cryptography, cellular systems, that if you tie them together in the right way, you get to a new kind of web infrastructure, which we call Web3, which is much more decentralized than it is today. The thing is, even though we have come quite close to where we think it's achievable with technological advancements in all these different areas, we are still left with often that there's no institution that really helps to facilitate these kind of developments. And therefore, in Switzerland, Zurich, there was a foundation created, which is called the Web3 Foundation. And today I brought you the mission statement, which is really that the Web3 Foundation was created to nurture and steward technologies and applications in the fields of decentralized web protocols, particularly those which utilize modern cryptographic methods to safeguard decentralization to the benefit for the stability of the Web3 system. So what does that mean? Their mission is that we have Web3 as soon as possible to bring it down. That said, just up front, that neither me nor Rob are representatives of the Web3 Foundation officially, but I think it's important to say that as it is one of these important actors to make all that happen, we believe. So, what belongs to all these? What are these set of technologies that we think need to be in place in order to get to this vision, the Web3 vision? So we have trust-free core technologies, blockchain technologies such as Polkadot, cryptographic messaging protocols such as Whisper. Many of you have probably heard of that before. Peer-to-peer networking infrastructure, most notably Dev peer-to-peer, which is the underlying protocol of Ethereum, as well as lit peer-to-peer, which is most notably used for IPFS, as well as crypto-economic mechanisms, often working on top of these core technologies, and that are combined to provide DAC or decentralized autonomous organization software. And last but not least, obviously, data publication systems such as APFS are really important in that way. And really, this foundation is there to research, develop, deploy, advocate, and steward these kind of set of protocols and technologies. So, to say that up front, we are really here to have an open call to all of you, everyone who's here, everyone you know, everyone who's excited about the space in general, to step up, come forward and say like, hey, I want to be a contributor. Doesn't matter if you want to be an educator or more on the research side, if you have good ties to the academia world, or if you're a developer or community leader. Everybody's really invited to get in touch. Here's the email address. Please get in touch if you want. And we really believe in a collaborative approach in the sense that, well, there can't be one institution or entity that provides this kind of set. That won't happen. Like, we all need to work together at the end in order to achieve that. And in that sense, Parity, that's the entity where I'm from, and Rob, is really just part of this whole ecosystem. Like, we are one entity, and we think and we hope we will make a significant difference in the end, but we are only part of that. So, yeah, a little bit of background. I'm not sure how familiar you are with our company. Could I see some hands? Who knows Parity Technologies, or formerly called ETHCOM? Do you know? Okay. So it's only half of it, I think. So I think I have to give you a little bit of background for you. So Parity Technologies was originally founded in early 2016 after Kevin Wood and a few other people left the Ethereum Foundation. And it really was created to work on this vision. And for that, we initially started with implementing a new Ethereum client from the bottom up. So we chose the development language Rust.
made really high performant and modular Ethereum client, which is broadly used right now. I think more than half of all miners in the world use our software to maintain the Ethereum network, as well as a lot of these businesses are built on top. So a lot of the startups or enterprises that want to use Ethereum or applications on top. But that's not all of it. We do a lot of research and development work on lower levels of the stack, which means, for example, Robert here was really substantial in implementing the Parity lifetime protocol. We are working on Whisper currently. We have brought forward technologies such as warp sync, if that tells you anything, which helped bring down the initial sync time from initially half an hour or an hour to like a few minutes. And yeah, that's where we work and who we are. So let me tell you a bit about this new project, Polkadot. Over the past years, we've seen a lot of different blockchains popping up, all of you. And what we believe, there are a few key failures of current blockchain technology that should be addressed. So first and foremost, obviously, scalability. Scalability solves around how much resources are needed in terms of bandwidth, processing, storage, to facilitate one transaction in a network, as well as like how many transactions in sum can be processed at peak time. That's really what scalability is in that sense. Isolation or isolatability is, there are so many different needs on the application layer. Different people have different applications in mind, and those applications have different needs. And the question is, can they all be met, these kind of requirements and needs, under the same network? For example, with Bitcoin, which is very limited, people found out it's quite not feasible to, for example, build a very elaborated decentralized application on top, and it's easier on something highly functional like Ethereum. Developability is another one, which turns around more like what tools are available for application developers to securely and fastly develop applications on top of this core infrastructure. What APIs do we have? What SDKs or what IDs? Applicability. Does the network we have actually solve a problem? Does it serve a real need, or is it just cool in the end? And last but not least, it's governance. I mean, we've all seen it with Ethereum, with Bitcoin. That is a quite important problem. How inclusive can we be? Can we build the tools that everybody feels well treated in the network? Everybody has a right to say and so forth. And with Polkadot, we try to address all of them in a sense, but most notably the first two, which is scalability and isolatability. So, to give you a high-level understanding of what Polkadot is, I want to tell you a bit about these 3 properties that we really think are key to what we're trying to achieve. First of all, we have extensibility. You can also call it modularity or upgradability. So, over the course of the next years or the next decades, we will see a lot of different technologies involved, a lot of progress being made in the reign of decentralized consensus systems, state transition machines. And we really believe that these kinds of technology should be able to come into Polkadot as first-class citizens. So Polkadot should be upgradable in that sense. So if other people come up with better ideas, Polkadot should be able to absorb it. Another one is scalability. Obviously, that has been bugging the whole blockchain community since day one. I think at most currently public blockchains can process 30 transactions per second, which is obviously not enough. And we believe that we have means to achieve at least scalability that will be sufficient for the development of the next 5 to 10 years. I will tell you a little bit more about that later, how this is going to work. And last but not least is heterogeneity, which really is, hey, do we really assume that all these, usages and how these applications are being built on a core level should be similar? Or do we say, hey, we want on this really even on the lower core technology level that different pieces can look very different? And if we look at the current approach, we often see that there's a single chain with varying degrees of generality over potential applications. So what does that mean? Well, if you look, for example, at Bitcoin, Bitcoin features a relatively simple scripting language, which almost resolves around like adding and subtracting numbers from balances that have to equal 0 in the end. In contrast, Ethereum is much more functional and open and features a much more Turing-complete programming language. But what you see with all of these blockchain technologies is that two very fundamental parts of consensus mechanism, which is number one, the state transition mechanism, which means what are the actual rules of how I transition from state 1 to B? How does it work? Like the machine, as in Bitcoin is a much more simple adding machine, and Ethereum is much more generalized computer. In contrast to the consensus canonicalization mechanism, the consensus canonicalization mechanism, next time, which really determines more like the ordering of the transaction, which takes care of finality. And what we see that in current blockchain technologies, these two parts are fundamentally tied into each other. They are fundamentally tied into each other. They are one thing in Ethereum, Bitcoin, and most, as far as I know, all the other systems we've seen so far. So Polkadot really takes a different approach here. There are two fundamental parts in Polkadot, which is one or eventually maybe more relay chains, multiple relay chains, and many parachains. The relay chain does really two things. Number one, as the name states, it allows to relay, so pass messages from one chain to the other in a trustless way. And the other thing is, it takes care to finalize transaction of on all these subchains, on all these parachains. But it's very important that to understand that the relay chain tries to tie together the finalization of transaction on all these parachains in the loosest way possible. That means it doesn't make assumptions about the rules that are enforced on the parachains itself. So how this machine works, does it work more like Bitcoin, more like Ethereum? It doesn't care. And the parachain instead is the machine itself, which can then look more Bitcoin or more general like Ethereum. So it's really like Polkadot, pick a mix. Have parachains that look more like Bitcoin, have them more look like Zcash, like really privacy preserving blockchain, or other stuff you can think. So bring it back. It provides two things fundamentally. Pooled security. All constituent chains, all parachains of the community are guaranteed a level of security through this finalization method. And the other thing is trust-free transactions. So parachains can send transactions and data and messages to other parachains in a trustless way. to take a look again at what this pooled security means. So currently, really, the whole set of actors and processing power or staking power for current blockchain technology, it needs to be separated for all these networks. For example, if you look here it says like, of these, if that's all hashing power, it's separated into 70% for Litecoin and 30% for Zcash. Obviously not the case, but it's just an example. In Polkadot, we look more at a shared security model, where you say like, hey, the relay chain, which really secures all these machines, all these blockchains, everyone who provides security should be part of that and should lend these security guarantees to their children. And like, as I said, if you look at the history of the past years, we've seen a lot of different blockchains coming up, right? Some look more like Bitcoin, some have properties like Zcash. You even have private and permission blockchains that work in enterprises. And what, at this point, we really believe there's not going to be a future where there's one chain to rule them all, but rather an ecosystem of very diverse chains, all fulfilling their purpose, all being there for the needs of different user groups. And Polkadot really, the problem with that is that currently all these chains that we see are very isolated. They can't talk to each other in a trustless way without having to resolve back to the old trust model. That means like using a centralized, a central party that transmits messages between those. And that's really where Polkadot comes in. Polkadot is there to enable messages between those public open blockchains and private blockchains. Polkadot really doesn't care what it looks like or how does it work. So just to give you a brief example, like a very, very concrete brief example, you unfortunately can't read that. Imagine you had a user that wanted to participate in an ICO because it's currently such a hype. It could talk through Polkadot over a bridge through the public Ethereum network as it stands, like a contract on the public Ethereum networks. Then interact with a private banking chain, let's say a Korean private bank chain, where one actor says like, hey, I know this guy, I certify he is real. He is real and like I've checked his ID. Then he sends back a transaction. And then this smart contract again moves assets to another parachain, which is, for example, the Melonport parachain. So much more of an asset trading blockchain, which again can communicate back. So you get this network of very diverse blockchains that can all function together. And you can call from a smart contract on one blockchain into a smart contract on another blockchain without having the need of the central party in the middle. And that's really what we are trying to achieve with Polkadot. Now, I think we want to go more into the tech details, so get really to the ground. But I would like to ask you questions already. So, not specifically about the inner workings, but more about what we're trying to achieve. If you have questions already right
질문 있으신 분이 해주시면 돼요.
now.
Do you suppose Ethereum is the only relay chain? Right? Do you suppose Ethereum is the only relay chain?
So the question is if we support only one relay chain?
Yeah.
So the idea is that initially, that is my understanding, Polkadot there will be initially one relay chain. But in order to further scale the system, there might later on be a hierarchical tree of relay chain, of many blockchains that serve as another layer of relay chain with many parachains on
Ethereum is the only relay chain now.
Initially, it will be started with one relay chain. Yes, if that was the question. Yes. But the idea is really, for example, if you have an idea for a new blockchain, right? Currently, it's really hard to spin that up because what you got to do is you got to have to convince all these actors out there to secure your chain, right? So in proof of work, you have to convince miners to work on your blockchain. In proof of stake, you need to build up this network first, right? This ecosystem of people having tokens and then staking the tokens. The idea is Polkadot will be this deployment and test bed for people that say like, hey, you know, I have a good idea for a state transition mechanism. So how the blockchain looks like it works, but I can't take care of the security aspect. And I just convince the what we call validators on the relay chain to take me into this network. That's the idea behind it.
그리고 한국어로 질문하셔도 괜찮거든요. 견딜 수 있으니까 편하게 질문해주세요.
질문하시기 전에 자기소개 한 번만 해주세요. 간단하게 성함이라도.
Yeah, so I'm Sian from the Blockchainers. They asked me to introduce myself. Can you elaborate a little bit more about like trust-free access to each other? Like what trust-free access means, what that looks like?
So trust-free in that sense, I'm just going to cover the high-level part right now because Rob is going to go more into detail. But like it's really important to understand because that's one of the most critical or important aspects of it, right? That's why we bother. That's why we're here. So trust-free in that sense means, what I try to say is that, imagine I'm in one blockchain network, right? Let's say, stay with current technology, Ethereum, and he's in Bitcoin, right? And, you know, I have a smart contract on my blockchain that does some logic, or release a message if something happens. And I want to tie that to a transaction that has to happen on the Bitcoin network. Let's say this guy, if this guy gets from another address, like 1 Bitcoin, then my contract should execute. Well, you need some method to relay transaction in between things. So the current approach is that you have somebody, like an oracle, who vouches for it. So somebody who's on both, and that we both trust, and he would say like, hey, I saw on the Bitcoin network that this transaction actually happened, so hey, yeah, you can go ahead with smart contract on Ethereum. It's all fine. With Polkadot, through like a very clever crypto-economic system with incentives, we want to ensure that this happens without the need for this central actor. So this is not needed anymore. Like, we can just join the network and we know if we do that, it will happen in a trustless way. And trustless in the sense that we don't have to go back to this old trust model. Yes,
Sorry. May I interrupt you for a second because of the presentation materials uploaded to the middle page. There are some people can't see your pages because it's too small. So we uploaded your material to the middle pages.
이게 지금 지금 이게 너무 작아서 안 보이잖아요. 프레젠테이션 내용이. 혹시 너무 멀리 계신 분들은 그냥 앞에 끌고 와서 앉으셔도 되고, 지금 제가 불편하실까봐 미더 페이지에 댓글로 이 PDF 파일을 올려놨거든요. 너무 작아서 안 보이셔서 지금 질문하기 좀 힘드신 분들이 있으실 것 같아서 그 미더 페이지에서 자료 보실 수 있으니까 보시고 질문하셔도 괜찮고, 이 다음에도 계속 보시면서 진행하셔도 괜찮을 것 같아요. 앞에 자리 많으니까 나오셔도 됩니다.
You mentioned that the Polkadot is trying to be the best path for innovation. A lot of like parachains, right? But I've got a question about your long-term vision. Like, are you try to make the Polkadot remain as the task path for innovation, or do you think it has a sort of really sort of like relay chain for every sort of a parachain?
No, so let's have Rob will go into that. You won't have a relay chain for every parachain. Like the idea is to have one network, which is a Polkadot network.
Yeah. So there's a relay chain and there's a separate parachain.
Exactly.
Yeah. But what I want to ask is like, you want to remain as a passpad or?
No. So
Yeah,
the really exciting and interesting part is that in the same network, you can have, for example, a production-ready chain where there's real money on it, right? So there's real money, and at the same time, somebody else tries out new technology. It's in the same network, but, and that's a really important part, it's isolated. That's what I meant with isolatability, right? It's,
Okay, so this one, yeah.
yeah,
The
I will elaborate on
Yeah,
that.
so
That's right.
parachain, the compromised security of the parachain does not affect the relay chain. Yeah, because to do a lot of innovation, you're gonna see a lot of failures as well. But it's not affect the relay chain itself.
So the question was if you compromise the security of a parachain, if that affects the relay chain, and therefore like multiple pairs or many pairs. So that's a very interesting question, and the thing is there are multiple aspects to it, right? And when you say compromise the security of the parachain, if you talk, for example, about the finalization, the ordering, the chemicalization, I mean that's a concern of the relay chain in the first place. So if that would mean if you compromise it on the parachain, you have already compromised it on the relay chain level. That's the reason why we talk about pooled security, because if we have parachains and here's a relay chain, right, that provides us with the security. So like in order to compromise the security of a parachain, you have to compromise the security of the relay chain in that sense. But I mean, there are many aspects to it. Another one's like how valid transactions are and so forth, but I'm sure Rob will go into it. No.
So that's one simple question. My name is Erica, came from Connector. I'm very interested in governance issue, and I agree that it's a very big problem in the current blockchain industry. You mentioned the consensus canonicalization mechanism. Can you just give like a brief definition of what it is that you think?
Canonicalization means describes the ordering, the finalization of the ordering of transactions, and it determines which of multiple valid history, which of multiple possible histories is the one we look at.
So you said the priority.
Nah, not right. Let me see.
I have a question.
Yes.
You mentioned the commercial banks, and so the centralized services like the commercial bank servers can be a single parachain in a Polkadot. And how does it work?
Yeah. Basically, on a high level, what these bank chains want to determine is how their machine works and how the validation function looks like internally. So what is possible, how these transactions look like. And what Polkadot provides is like, it says, hey, you can figure that out and even have like, for example, a proof of authority consensus mechanism where you have like a few banks that say like, hey, this is valid and so forth, and they feed that to the relay chain in some sense. And in that sense, right, you preserve the sovereignty for these kind of actors on this level. So for the banks, they still have sovereignty over how their machine works and what is valid and what's not. But at the same time, you get the security and the trust-free messaging, like being part of one network by being part of Polkadot. I think most of these questions will be also like already answered by him. But like I would say we do another round right after and like go into more detail, if that's okay. Cool.
Hello everyone, glad to be here. So Bjorn did a quick introduction of me, but just to reiterate, my name is Habermeier. I am a core developer at Parity Technologies, and I'm also one of the lead developers on Polkadot. So now I'm going to be going into what I call the nitty-gritty of Polkadot, which is how the tech is really going to work. So Bjorn gave a nice overview of sort of the philosophy of it, but now for those of you who are very technically inclined, this is where you're going to get a good intuition of how we're starting to implement this. So there are two core pieces of Polkadot. We have the relay chain. This is the main chain. It's a top-level chain that coordinates transactions, messages, and state transitions of parachains. And parachains, you can think of it as where the magic actually happens. You can have many different kinds of parachains, each one with its own state transition mechanism. And this would be like, well, I'll go into it a little bit more in detail, but you can have different kinds of parachains that cover features like privacy and cover specific kind of transactions. And by specializing the functions of these parachains, we can achieve higher throughput. So the relay chain is very simple. It has no complex functionality, and it also doesn't have general smart contracts. So you wouldn't have something like an Ethereum virtual machine that runs on the relay chain because we want it to be very simple so that it doesn't become a bottleneck. And also that fees for passing messages through the relay chain may be levied based on the stakeholders' choices. This is a system that's going to be governed primarily by the stakeholders. So there are three kinds of parachains, and this should answer a lot of the questions that you guys were posing before. So first we have open parachains. These are the most typical kind of parachain I think that you would expect. And these are parachains that are completely controlled by the relay chain in some sense. So they just define what kind of transactions they perform. They define what makes a valid transaction, what kind of state, what kind of smart contracts, privacy, whatever. And then the validators of the relay chain are responsible for ensuring that the transition of this parachain is correct. Closed parachains are, going to answer your question, closed parachains are how we intend to implement consortium chains, and that's what this diagram here represents. So you have a consortium parachain, and the consortium consists of a group of different authorities. There's special people in the consortium who are supposed to agree upon what the state of the consortium chain becomes. So the parachain validation function for a consortium parachain is just whether the authorities have signed off on it. So actually the relay chain doesn't necessarily check the validity of the transactions that are happening in the consortium chain, and they may not necessarily be available. But what is available is whether the authorities of the consortium have signed off on it. And lastly, we have bridge chains. So bridge chains are parachains that are loosely connected to Polkadot. This would be something like Ethereum, Bitcoin, or Zcash, existing chains which provide their own security, and that we want to connect to Polkadot. We have this existing ecosystem of a lot of different kinds of chains that are interacting, and people are building applications on top of them. And Polkadot, obviously, when we release it, these things are still going to exist, and they will exist for some time yet afterwards, a long time. So we're writing bridges to connect them to Polkadot. That messages can be relayed to chains that are secured by other consensus mechanisms as well. Who powers Polkadot? There are four key groups of players in Polkadot. The first is validators. This is a proof of stake system. That means that there are specific validators who, when there is a new block to be produced, they have to sign off on whether it is valid. They have to produce, they have to come to an agreement together on the new state of the Polkadot relay chain. And they are staked, which means that they have put down some money. And if they are caught misbehaving, then this stake will be burned. That's what we call a proof of stake chain. Nominators are similar to validators in that they're staked, but they don't do the validation themselves. Their role is to select good validators and vouch for them. So if you have too many validators, then the communication between them when you try to advance the relay chain will be too great. There's too much communication happening. But we still want to have a significant proportion of the staking tokens on the relay chain allocated for security purposes. What this means is that we introduce nominators who are, their role is to find validators who they believe to be honest and then delegate some of their staking tokens to this validator. And if that validator is then found to misbehave, the nominators who have vouched for them will be slashed. Then we have collators. So keep in mind, Polkadot is a system made of many different parachains, and each of these parachains themselves can be quite complex, and they have their own kinds of transactions. So for each parachain, you have collators. So what a collator does is he picks a parachain, and he says, I'm going to accumulate pending transactions for this parachain. And then I'm going to prepare a candidate block for the parachain and a proof that it is valid. And then I'm going to send that to a validator to be included in the next Polkadot block. So the key thing here is that the validators themselves don't do the work of accumulating transactions. And this is one of the ways that we scale. The coordination of propagating transactions and parachain-specific messages happens off-chain, and then they are sent to validators. And the validators, because they don't have to do all of this extra work, can become knowledgeable about all the parachains to the degree that they can provide security for them. And lastly, we have fishermen. So fishermen are instrumental to the security mechanism of Polkadot. The idea is that we have all these different parachains, and then we have all these different validators. And on every Polkadot block, we say, this group of validators will be validating this parachain, and this other group will be validating that parachain. And we have to create something that's called Byzantine fault-tolerant consensus, which is, what if some of the validators are malicious? And when we're starting to split up the validators like that, then the likelihood that the validators on any single parachain are all malicious is not zero. It could happen. So this is why we need fishermen. Fishermen have a given amount of time where they would watch for making sure that all the validators are behaving correctly. And then if they can prove that a validator misbehaves, then they will get a reward. And this is how we achieve security in Polkadot. So why do these groups bother? I've laid out sort of their roles, but it's very important that we be able to achieve what you might call like an equilibrium, that each participant in the network actually has an incentive for keeping it secure and also keeping the network running. So the validators and nominators, they're rewarded because they get block rewards for staking. So the validators are issuing new blocks on Polkadot, and they're rewarded for this work if they do it correctly. The nominators are vouching for validators, and they're rewarded for vouching for validators who behave honestly. The collators, who individually, each collator has picked a specific parachain that he will work on. The collators will get parachain-specific transaction fees. So you could imagine a parachain which is a lot like Ethereum, and then each parachain block just consists of some Ethereum transactions, a lot like what we are all used to here. And they get the mining rewards for executing those transactions, not the validators. And then lastly, we have the fishermen, who are gifted a proportion of the bond of the identified culprit. And this is kind of opaque language, but basically what it means is if they catch a validator misbehaving, and this validator has a security bond, then the validator's security bond is burned, but the fisherman gets a portion of that. And this is actually where some of the more complex details of the game theory that we're looking into arise, because the fishermen, if you expect that nobody will ever misbehave, then the fishermen wouldn't have any reason to participate. So we need to create a lower bound, a reason for fishermen to believe that somebody would ever misbehave. So what we'll do here is maybe something like what's proposed in TrueBit, where every once in a while, the validators are forced to create an invalid block. And they wouldn't be punished for that if they can prove that they were forced to create it. But then also, the fishermen have a reason to watch out. So, I know I just dumped a lot of information on you guys. We will return, don't worry. But here's a diagram, this is a picture. You can look at it. So, as you can see there, we have the relay chain. We have these parachains hanging off of it. I hope I won't block too much of the screen here, but we have a parachain here, we have the Ethereum bridge, and then we have sort of a zoomed in parachain. So this is sort of to be the same thing as this, but we've zoomed in on it and we're looking at all the different roles. And then this is what Bjorn was talking about earlier, where we want to create a tree of blockchains so that we have a relay chain, and then we have another relay chain hanging off of it. So we have this scalable tree that could potentially grow to infinite size. So Polkadot's relay chain does two things. The first innovation is that we have grouped all of the state transitions of the different parachains under the same consensus mechanism. The second thing is that we enable trust-free communication between the parachains, because this parachain can say, I want to send a message to this parachain. And this is something that was not previously possible. So on top of unifying all the parachain state transitions under the relay chain consensus with the validators, of course, we've also got this implicit message passing that lets us do very, very powerful things, like hold tokens for one parachain on another. And then you can see this parachain at the bottom is a little bit special. It's a bridge. So the Ethereum parachain there is not actually a parachain because it's the Ethereum network, but we have a bridge that is a parachain and connects to the Ethereum network and relays the message. That's basically what this covers, but I understand the text is quite small, but it does basically just say that. And then I'll describe a bit, again, with the picture, what these roles are. So we have collators. So you can see on this green parachain here that there are collators here. So the collator is on one parachain. He's just on the green one. He's not on the pink one. He's not on the relay chain over there. He's just on one parachain. And all parachains will have their own groups of collators. And what they do is they can see there are new transactions that want to be included on this parachain. So they come up with a list of the pending transactions, and then they send it to a validator. The validators are doing this. They're validating the blocks that they get from the collators, and they're also routing messages. And fishermen, again, are just on a single parachain, like the collators, and they're making sure that the blocks that the validators include are indeed correct, and the messages that they include are indeed correct. So we'll talk about governance a bit too. It's very likely that we'll try to take some hints from existing governmental structure, something like a two-house system. You know, in the US we have the Senate and the House of Representatives, and in the UK you have the House of Lords and the House of Commons and all this stuff. And this is a system that's to some degree tried and true, and we'll try to emulate this on Polkadot. But the key thing is that it's stakeholder driven. Those who hold the staking tokens have the say. That means to some degree things are put to coin votes, and that there will be a proposal mechanism for people to put forth additions to Polkadot, changes to Polkadot that can be included just by achieving the majority consensus of the stakeholders. And there's also this idea of making it community focused. So this is not solid, this is not necessarily something that we will for sure do, but it's an idea we've been playing with, which is that when the validators get a block reward, they don't always necessarily get the whole thing. They might have a configurable fraction of that block reward sent to them personally, and then the rest of it is put into a decentralized autonomous organization, a DAO, to be managed by the community. And this proportion could be configurable based on more voting. and then the withheld portion could then be used for community projects. And we can control the issuance rate, inflation, and parameters like that. And this is where we are more or less now with development. So for those of you familiar with Parity, you might know that we have an Ethereum node software. But actually, it's a lot more than that, because to some degree, it is generalized over what kind of consensus mechanism we use. And one of those consensus mechanisms that we have is something called proof of authority, which is sort of like for consortium chains, where you have this set of trusted authorities, and then if the majority of those agree on transaction, then that transaction is included. So from proof of authority, our goal is to get to proof of stake. So we're starting to do the research, we're trying to build a solid proof of stake algorithm, and we have an Ethereum test network, which is currently running proof of authority. And one of the big milestones for testing this proof of stake algorithm that we're building is also to write a value-bearing testnet. And for those of you who like to play with decentralized app development, this might be something really cool for you to play with. We're also working on light client support. So a light client is a client for a blockchain which validates that consensus is done correctly, but it doesn't actually check that transactions are correct. It sort of places faith in the consensus mechanism. But if it is given a proof that transactions are correct, it can check this proof. So we have an Ethereum-like client, and we would also like to bring this to Polkadot as well. And the last key piece, most important piece, is that we are also writing, we are in the final stages of writing a bridge to connect two Ethereum chains. Say the Ethereum mainnet and the Kovan testnet, which is this proof of authority testnet I just mentioned. And this will eventually become the bridge that connects Polkadot to the Ethereum mainnet. There are also a lot of different groups in Polkadot. There's the collators, validators, nominators, fishermen, and these groups have pretty complex patterns of communication which may be constantly changing. And what we're starting to find is that the existing frameworks for peer-to-peer communication aren't quite enough for us. So we're taking the existing dev P2P peer-to-peer communication library that's used by Ethereum, and we're trying to extend it, and then we're going to play a bit with Protocol Labs, IPFS's libp2p. We're trying to find something that's really suitable for the kinds of complex peer-to-peer interactions that Polkadot requires. And then we're also doing work in the Parity node to generalize over state machines. So we'll have a generalization over consensus, as I mentioned before, but also state machines, where you can choose what kind of transactions your blockchain will run, and you can come up with a new system like that. So if you'd like to follow the progress, we do everything open source on GitHub. You can check this organization here, github.com/W3F. This is where Web3 Foundation code will go. And then github.com/paritytech/parity is where the Parity node implementation lies. And if any of you are programmers here, we're writing it in a language called Rust, which has a focus on safety and speed. And we are really eager to accept open source contributions that we mentor issues and we categorize them by how difficult they are. This is something that we're really eager to get the community involved in. And if you'd like to chat about the Polkadot white paper, the specifics, there is a Gitter chat room here at this link. And for technical information, you can go to polkadot.io. And if you'd like to find out more about Polkadot in a more abstract sense, you can go to polkadot.network. And there is some Twitter here, you can get pictures of that. And I'll take questions again. And I would be glad to revisit any of those slides because I understand there's quite a lot of information. But yeah.
Yes. Can you give some simple example use case for what Polkadot is doing?
What it does?
Your presentation is very abstract for me, so can you give some use case? Simple
Okay.
example?
I think that's more.
Yeah, so use case, right? So, use case number one.
And here one more question. And here one more question.
Yeah, one question.
You said about the validator and nominator. Is it similar to endorser order in Hyperledger?
Is it similar to what in Hyperledger?
Endorser and order.
I'm not sure about the terminology that Hyperledger uses, but I would venture a guess that it's similar. I'm not sure. I can't speak with authority on that.
I'm not quite endorser or nominate. I wouldn't think so because endorser would come specific to some specific state condition instead of. A nominator, I don't know if you understand what a nominator is. So a nominator really is like, imagine I'm a participant of Polkadot and I hold stake, right? I hold dot tokens. And now I say, hey, I don't want to be a validator, so I don't want to run software, but I want to be part of the security mechanism in the sense that I say, okay, I have these tokens and I know him. And he's a validator. He's okay with running software. So what I do is I take my stake that I have and I nominate him with my stake to be a more powerful validator. So that's the idea behind it. So is it similar to what you said?
I think it's similar, but I'm not sure.
But why I don't think so is because as far as I know, Hyperledger, or I think you're talking of IBM Fabric, you're talking about IBM Fabric. IBM Fabric is not using, to my knowledge, a proof of stake system. And that's why I would be highly surprised if it's similar in that sense.
So, and then speaking about general use cases, part of the goal here is to facilitate trust-free communication. So we could have public permissionless blockchains, something that runs smart contracts, like ERC20 tokens, if you know those on Ethereum. But then we could also connect this through the relay chain to a consortium chain that's managed by a group of banks. And then you could hold US dollars or pounds or whatever as ERC20 tokens on Ethereum without having to trust some kind of federated peg, which is a little bit less.
So how can you connect to it?
Well, it's connected via the relay chain, so that messages are sent via the relay chain to the smart contract. So you can have a message, you have this Ethereum-like parachain. It's not Ethereum, it's not a bridge chain, but we can imagine one that acts just like Ethereum and it is a parachain. So other parachains can send a message to this one that says, call the contract at this address with this data, and the validators will relay this. And we can also have messages coming out of the Ethereum parachain into other ones, and this way we can have smart contracts that sort of bridge the gap between different
So
parachains.
for me, the Polkadot network is kind of another chain to connecting Ethereum or cash. But I don't know exactly.
Yeah, Polkadot, exactly. Polkadot is, at its heart, it is a relay chain that's designed to pool security so that you can have all kinds of different transactions or whatever under the same source of security, and also to connect different chains.
So once you develop the Polkadot, you have to release some tokens or stake.
Exactly. So the relay chain, in order to function, because it resolves around proof of stake system, there needs to be the notion of a token. Yes. But the fundamental difference when you say like, oh, it's just another blockchain is that the relay chain really isn't there to provide any kind of functionality rather than enabling all these other chains, right? So it's not like you're not going to say like, oh, I use the relay chain to execute the smart contract. No. So the relay chain only takes care of securing these chains and relaying messages. And that separates concerns, so to say, and makes it, gives us reasons for it to be a lot more extensible in the sense and scalable through the parallelization of these chains, right? Because if you have multiple chains running at the same time, you get parallelization of transactions, and that's the initial way to scale in that sense. So when you talk about use cases, right? I think it's a reasonable assumption, or I have seen this assumption to be kind of proven in the business world, that enterprises won't hop on a public blockchain right now. They won't do it. For, let's say, reasons of finality, for reasons of they can't determine their own validity of transactions, and also everything's public. So, for example, on Ethereum, right, you can see all the transaction data and so forth. That's not okay. That will not be okay for in most scenarios at the moment. And we think it's way more likely and reasonable that you have these, for example, a banking network figure out how their transaction, their state transition machine works. For example, for a banking blockchain, you don't need this elaborate machine such as Ethereum, which is so highly functional that you can build everything on top. But rather, like, they have very specific needs in terms of what this machine can. So, and by having, for example, on this level, right, on this level in between the banks, a way more limited functionality, you can also potentially make it a lot more secure. But what you want in the end is that this bank chain can talk to the supply chain blockchain of, for example, an enterprise network with its suppliers, right? And that's where Polkadot comes in. For that and for the pool security, that either the banking chain doesn't have to take care of its final transaction and it's actually secure, neither nor the supply chain blockchain. That's the idea.
But this only possible when the bank credit poker chain. But can
a parachain. So exactly. So therefore, one of these groups would have to create a blockchain. I would say a chain, a parachain that fits into the Polkadot framework. But the critical part is that we try to keep it as general as possible in the sense that you don't have many limitations in the sense of how your parachain looks like. So neither on the consensus level, I mean, you can say like, hey, we want to be more like a closed chain where other people can't even look into, and we just hook onto the relay chain on a level like we don't even use the consensus mechanism of the relay chain for our own ability to come to a new state. I hope that answers the question. So this is a use case on the more production level, in the more production level area. Another one is, as we said, like innovating. Just keep innovating. Like people, it's a really hard part to take care of the security of your chain. And also the problem is, before it's not secure, nobody really is going to use it. And you saw it with Bitcoin. Everybody said like, okay, it's only going to be Bitcoin because you know, the chance that you build up an ecosystem and a network, that there are enough people that either stake or mine is so unlikely it's not even worth the bother. That shouldn't be the case. You should be able to innovate under this hood, under this framework.
So there are four main players: validators, nominators, collators, and fishermen. I think the collators are parachain specific, and other validators, nominators, fishermen, they're not.
Fishermen are also parachain specific because fishermen have to. Well, I'll use the microphone because fishermen have to access all the data for a specific parachain in order to ensure that what was included in the relay chain was accurate. And this is the only way that they can prove misbehavior, by trying to see if, given the full data of the parachain before the block and then after, and making sure that it makes sense.
And the relationship between validator and nominator reminds me of delegating. Like, is there similarity?
It is a form of delegated proof of stake.
I mean, you nominate, you delegate.
And they're staking with the token that is issued by what kind of
Yes,
tokens
yeah.
they use?
So the nominators also use the staking token. So on the relay chain, there's only one token, and the validators hold this, and the nominators hold this, and they stake it. And if they are proved to be misbehaving to some degree, then their stake is slashed.
But the nice thing is like you can have completely arbitrary different rules on the parachain. Like really, they don't even need to have a token. It can be like some other kind of data structure in that sense, any kind of state. And that is like really hard to grasp when you come out of that field, but that's ideal.
Although in one parachain, there will be many layers, right?
Yes.
Many
Yeah.
different blocks. But how can validators cannot economize between those different blocks? How do they know that which is
Yeah. So there are a couple.
most valuable?
There are a couple ways that we try to ensure fairness amongst collators. That the same collator doesn't end up issuing every candidate for the parachain. We have an idea that the collators will have to sign their block. Like when they produce a candidate, they'll sign it, and then maybe we have a random value on each relay chain block, and the collator whose candidate has a signature closest to this random value is the one that we select. So this sort of creates a uniform distribution.
How can you
of
prevent
fairness.
single attack by faking a lot of IDs?
Well, you would have to mine a ton of IDs. It's very hard to get arbitrarily close. And the thing about dealing with random values is you always have to have some kind of like usurping mechanism that, okay, you do a civil attack and you create a ton of IDs, but you don't necessarily know that nobody has an ID which is closer than you do.
So, for the collators, their incentive, their economic incentive and transaction fees. And what happens if there's not many transactions that are happening for the university participant, and then there's not much transactions happening in here, and there won't be enough collators to collect it and relay to the exchange. So, is there any
So the interesting thing is that if you have a parachain where there are no transactions happening, then an update for that parachain doesn't have to be included. There's not much point in an empty update. But there's also another aspect in transactions. There is messages going in. So if some parachain wants to send a message to a parachain which isn't having any transactions, the collators still get paid for applying this message.
So the validators, they maintain global state of all parachain.
No, that is also a key point, which is that each validator is a light client for every parachain, which means that they have some rough information about the parachain and that they can validate proofs of transitions on that parachain, but they don't store everything because this would be too much of a burden. So collators store everything for a given parachain, and then they provide proofs to validators who can check those proofs, but the validators themselves don't store everything.
And this is fundamentally important because otherwise it wouldn't be scalable. If every validator, or if they ever would hold the full state of all the chains, parachains, it wouldn't be scalable because you wouldn't really parallelize anything.
So basically, players are responsible for all the state transition, and then validators are only the lifeline and checking only the proofs, but whether that transition is valid.
Exactly. So what we do if we, let's say we form our validators, right? Let's assume that we have 4 validators here, right? On the stage here. So, and we have 2 parachains. What happens is that for every new round epoch, we call it epoch, I think, the validators are split up into sets who take care of one parachain for the next epoch. And this is randomly generated, right, through some mechanisms, so different to proof of work, where it's being done through the hashing power, right, as you all know. So this is different, but that's basically it. We have all validators are split up into sets of validators that in one epoch, so for one new round, will look after one parachain. And each of us validators have our buddies, our collator buddies, right? So for example, I know these, 50 guys that 10 of them look after this parachain, 10 on the others, and they run a full node. So they always know the full state of this particular parity. And what happens is, as Rob just explained, is let's assume I'm a validator, right? We are assigned to this particular parachain. Then I talk to my collators on that parachain, and some kind of mechanism tells me what collator should be the one that provides me with the block. I ask him, he provides me with a light client proof of the new block. I validate that in between my set of validators, and then bam, it goes into the relay chain. And that's when it's final.
Yeah.
Oh, or like, yeah, you know whatever. Because it can be reorganization. That's why I always.
Yeah, and also imagine a situation where there are 4 validators, let's say, and then one of them is malicious. So every time he gets randomly assigned to a parachain, he just creates a bad transition. This is where the fishermen come in, because they're watching for those bad transitions on a specific parachain.
You talk about the nominators nominating with the stakes. So what's the advantage of the higher stake, the validator, than the smaller one?
That's a good question. So the percentage of staked tokens corresponds to the overall security of the network. It's like the amount of money that people are spending vouching for ensuring the security of the network. If this is too low, then it's easy to surmount it by, say, bribing all of those who are staked with a slightly higher amount than what is staked. So key observation is that validators are sacrificing like fungibility. They sacrifice the ability to move their funds around in exchange for more rewards later. So they do have an incentive to do this, but it also ensures the security of the network.
지금 시간이 조금 지나서요. 저희 미덕 마치고 나서 지금 치킨이랑 맥주를 좀 준비를 했어요. 그래서 저쪽에 BBQ가 있는데 BBQ에서 혹시 더 하시고 싶은 질문 있으시면 호가한테 같이 가서 좀 얘기 나누니까요. 그때 물어보시면 될 것 같고, 그다음에 좀 시간이 좀 지나서 치킨 좀 식었을 수 있어요. 그냥 식은 대로 드시면 될 것 같고요. 그다음에 여기는 지금 인터뷰를 마무리하고 끝나고 다 같이 이동해서 다 미시는 안 가셔도 되고 끝장 아니에요. 이동을 해서 마실 분들 오셔서 그 치킨이나 맥주 드시고 가시면 될 것 같습니다. 네, 그다음에 뭐 추가적인 질문 있으시면 오셔서 배울 때 물어보시고 하셔도 돼요. 마무리하는 시간이 있으니까요. 네, 오늘 미덕은 여기서 마치도록 하겠습니다.
네, 저희 후원금으로 기프리가 준비되어 있기 때문에 너무 경제적인 부담을 생각하지 않아서 괜찮습니다.